Welcome everyone to this week's SQL Server Training Certification class. Let me get a few things set up here. This week's class is on the 70-461 certification exam for SQL Queries, and this is what we're calling the Section 1 review. We outlined about what we're going to cover for the next, third to half of a year until we get through all the training, and we're about 25% of the way through it so far. So we just call that Section 1. It loosely maps to Book 2 in Book 2 in the Joes to Pros certification series, and we're going to be moving on to Book 3 next week. I will post on the website an updated agenda where we'll be going from here. But for now, we're going to go and review what we've done over the last several weeks. My name is Steve Stedman, and I will be presenting today along with Aaron Bouma, and we will be following up on everything that we've covered over the last several weeks. Welcome for all of those joining us remotely. For any questions via Google On-Air Broadcast, we'll address most of those. Normally, we address most of those at the end of the training, but we'll address those at the end of each section as we can. So as we're talking or as we're presenting on something, feel free to shoot out questions. We'll either take it right there or we'll take it at the end of the section. Training is provided by Emergency Reporting. So part of what we're doing here is training everyone in emergency reporting how to use SQL Queries as much as we can. We figured we'll share that with the world. So check out emergencyreporting.com if you want more information on what we're doing. And all the slides and sample code are available at my website, stevestedman.com. You can download them there right now. I just want to welcome viewers from all over the world who are joining us. We've got quite a few people on the list. We've noticed a few that keep coming back every week. That's great to see you. This week we have people from Bellingham, Jacksonville, Florida, Riverview, Florida, Reno, Nevada, Glacier, Washington, Long Beach, California, and then international, Dominican Republic, Mumbai, India, Argentina, Belarus, Cape Town, South Africa, Trowbridge, UK, and Bucharest. So welcome everyone. Hopefully I didn't mispronounce anyone's city name there. Keep in mind we're using Google On-Air Broadcast for this, and for the On-Air Broadcast there's about a 40 to 50 second delay from what you see from when we say something until you actually see it. So when you're asking a question, you're asking it about 40 to 50 seconds delayed over what we're seeing. So just be patient with us on that. We're still trying to do the best we can to get the questions answered as quickly as we can. And all the sessions will be available on my YouTube channel about an hour after the presentation ends, as well as on my blog at stevestedman.com/YouTube. So questions, we will have lots of time for questions in this session, I hope. To turn on the Q&A in the Google On-Air Hangouts panel, up in the right corner, there's a little 3x3 grid icon. If you click on that and then select Q&A to see what people are asking or to ask your own questions. When you ask a question, keep in mind that's delayed for us. So the agenda of what we're going to be covering today is everything that we've covered over the last, about 7 or 8 weeks, it seems like. So we're going to be covering Null. Everything you ever want to know about Null and we're afraid to ask, or maybe not. Expressions, identity values, aggregation, top ranking functions, aggregation strategies, the output clause, derived tables, the merge statement, set operators, correlated subqueries, common table expressions, recursive queries, and ntile and analytics. Now, that's a lot to get through, but keep in mind this is review. We've covered all of it. We've touched on some of it before. If there's something that we don't have enough detail on, feel free to go back to the previous week's broadcast and check that out for more information. We do have 5-minute egg timers here that we're going to be using to try and keep us on track. The goal will be each section that we present, we'll flip over the timer, and when the timer runs out, we're done presenting on that one, and we'll have a couple minutes to answer questions at that point. And over the 90-minute period we have here, we'll try and allocate about 15 to 20 minutes at the end to be able to answer any general questions on anything we've covered. And at the end of each section, we'll see what we can do to answer questions at that point. Okay, jumping into, make sure I get this shared right. Entire screen. All right, so to cover the topics, we've got the sample code open here in all of the sample code from the last sessions open here, and I just want to open it for anybody who has a specific request or something you want to know more about. Doesn't matter to me where we start with this, but here's the list of everything we want to cover today. Anybody have any preference where we start? Heard one person say at the top. Anyone else? All right, we'll start with aggregating data then. So that is Aaron's section, so he will jump in and present on the first bit here. 5-minute timer has started.
All right. First, we're going to create our database and sample data. It's the inventory store data. Aggregating data covers the count, sum, min, max, and average functions. We'll look how those operate. Run two queries here, one that just does a select star from the inventory table, and then the next function, sorry, store procedure query, sorry.
Off to a rough start.
Yeah, lots to cover. The first column is a count, and then we have sum, which totals the quantity on hand field, and then the min, max, and average. And we returned one column, the category, which we did not put a aggregate function on, so we needed to group by that function or that column in the query. So we can see the sum of axes, the count of axes, ax items, sorry, on hand is 1. We have 2 food items, item SKUs, and 3 sleeping bag item SKUs, and 1 tent. And sums up the quantity on hand for each of them. The min returns the value out of all the items in that group. That is the lowest. Max returns the highest, and average returns the average of all of them. Item here. So the count function returns returns a row count or a count of records that don't include null values. We can see here that the food category has 1 null record in it and 1 field that is populated. But we can see in the second result set that the count record only has a 1 instead of 2. So there's 2 different values. Null isn't really a value, but 2 different values, but the count is only 1. So how do we account for that? We can throw on a isNull around it and convert that null to an empty value, and then you will see a count of 2 values there. Right, so can we group on multiple fields? Yes, we can. So in this second query, we are grouping on category and a count of SKUs. Again. When we group on category and unit retail, you include them in the group by, but you also include both of them in the select statement. You have to have matching columns in each of them when you are doing grouping on multiple columns. Also, So this example, it was, so when you do ordering, and you want to order by the value of what you're counting, and this query that doesn't work is selecting category and unit retail and grouping on the item SKU, and you want to order by the total SKUs in each of those category and unit retails. You cannot put the actual column. You need to put the alias for that column. Oh, and 5 minutes is up. I'll just finish my example here. When you put the alias there, it works.
So now we take about a minute to 2 minutes with any questions on any of the aggregation that we've covered here. And I know we've just barely touched on it, but yeah. Feel free to ask anything related to that at this point. All right, well.
No questions? Okay, I will close that one.
We've had a request from one of the viewers to cover the ntile function next.
Okay.
So we'll jump into that now. I think that was my presentation.
Ntile. Steve. Yeah.
All right, get everything lined up here. Okay, so what we're going to do to jump into ntile, start our 5-minute timer. Ntile and analytic functions. So we're going to use the same query training database. We're going to delete it and start out fresh, and we're going to create this new table called revenue. And the revenue table has 3 columns here. We have the department ID, the revenue amount, and the year in which the revenue occurred. So down below here you can see the department ID of 1, department ID of 2, and department ID of 3 on this big insert statement, and then a number of values that show how much revenue there was each year, and then the third column is the years that's being inserted. So we'll just fill that out and with a bunch of years of data ranging from 1998 to 2012. Get 45 rows inserted, and let's just take a quick look at what's there. When we look at that, you can see a bunch of department IDs, 1, 2, and 3 in the first column, and a bunch of revenue amounts that vary year over year, and then a number of years. And for every one of these, we have 1 year and 1 revenue amount for each department. So let's take a look at what we can do with the ntile function. Now, the ntile is kind of what I look at as a generic version of percentile. If you look at percentile, it's based on 100, but ntile is a way of just saying like a decile, which I believe, if I remember correctly, is the splitting a group into 10 categories and finding out what point each value fits into that category. So what we're going to do here is we're going to select everything out of the table. We're going to look at ntile of 10, which says split every value into 10 categories and assign it a slot in there. And then order by revenue. So what it's saying is we're basing the ntile off of the revenue amount. I mean, if we did a percentile or an ntile calculation based off of like a department ID or a year, it might not make as much sense. But what we're going to do is calculate that percentile over the revenue field. And then we'll calculate over revenue, and then we're going to order by the year. So for each year, we can see how well the revenue numbers were based off the entire history of information we have on this. So highlight it, and we run it. And what you can see here, as we look at it, zoom in a little bit here. So we can see for department ID of 2, with revenue of 20,000 in 1998, that was at a scale of 1 to 10, the second worst year. There's only 1 year, that's in the bucket of the bottom 20% of all of the revenue values. If we look at the next one of 40,000 in 1998, that was at the 4th one. And as we scroll through the list here and find some bigger numbers, we can see down here these values of 90,000 are in the category of the 10, or they're at that 10th rank in the decile. So those are the highest ranked revenue numbers over the entire year. Very handy, very useful for figuring out like what are our 10 best years, or what are our top 10% of different things on that. Now let's take a look at another one, very similar. All I'm going to do here is change the percentile from 10 to 100. So this piece changed from 10 to 100, and I'm going to add an alias here called percentile. And when we run that, it's going to take all of those same values over revenue and calculate their percentile over 100 rather than 10 slots. But as we go through, well, let me size this up so you can see the result set here. And as we zoom through this, though, you would think what we're getting is percentile based off what we asked for. And if there were indeed more than 100 values in our result set, all of those values would have been distributed out over the 0 to 100 range. But what's really happening is it's because there's less than 100, there's only, I think, 45, we're getting the equivalent of passing through 45 on our ntile function rather than 100, because it just starts at the bottom of the list and ranks everything in position 1 through 45, because we only have 45 results there. So that's one of the gotchas you've got with the ntile function, is that when you're using it, if the data set is smaller than the number you're passing in, well, you're not going to get a true percentile in that case. Now here we're going to take a look at the ntile 20, which is similar, but just looking at 20 different buckets. And based off of the fact we have 45 values, we get about 2 to 3 in each bucket here. So the in this one, if you noticed, order by revenue, let's zoom in here. Size it a little bit. Order by revenue descending. So in this case, the bucket 1, as we're looking at here, the first bucket, in a descending order, this is bucket 1 is the best or the top ranked in all of it. Bucket 2 is the next category, and bucket 3 on down. So that's how the basics of ntile works. And we're up with our 5-minute limit on that one. Any questions on percent or on ntile before we move on to the next section? All right, I will close that window out. Any requests for our next section? What we've got, oops. What we have left to cover here is this list. Any CTEs? Introduction to CTEs. Okay. So Mark has asked for CTEs. We'll jump into that one. No problem. Let me click through. Introduction to CTEs. That's my section. So moving on to CTEs, flipping over our timer with our 5-minute start. Keep in mind what a common table expression is. It's a way of sort of wrapping up what you might normally put into a subquery into kind of a named type of a subquery. It also gives you the ability to do things like recursive queries and whatnot, which that's covered in a separate presentation. So let's take our standard database. We're going to drop it and recreate it. And we've got this table called royalty that has the British royal family in it, and a table called departments. And then we've got a stored procedure here called reload departments, which is just going to put a bunch of values into the departments. And then one called fill more departments, which we're going to use in a little bit. So what I'll do is I'll start it out. We'll create the database, set up those tables, and fill up the department. So let's just, for the purpose of this this demo and what we can look at in the first 5 minutes here, we're just going to look at departments. And the departments table, you can see here, each department has an ID, it has a department name, and a parent. And for the departments that have null parents, like you see here, that means they're top-level departments in the hierarchy. And then, for instance, the tents, backpack, sleeping bags, and cooking that have a parent of 1 here, that means those are all under the subcategory of camping. All right, so let's take a look at building our first CTE. So the way you start out with a CTE is it's kind of like how you would build a subquery. So I've got this section of code I'll highlight here, where we're going to select 3 columns out of departments. It's about the same as what we just did with select star from departments. And then we're going to wrap it in a CTE. And CTEs, or common table expressions, always start with the with statement. And it's good practice to put a semicolon in front of it, because with SQL Server T-SQL code, you don't always have to terminate the previous statement with a semicolon. But with CTEs, if you do not terminate the previous statement with a semicolon, the CTE will not run. It will crash. So the semicolon is required. I just put it in there. If you're really good with your semicolons, you know it's always going to be on the line before, you don't have to put it there, but I just put it there for good practice. We give the CTE a name. Here it's department CTE, and that's going to be referenced down below here as department CTE. We declare the columns that are coming back, and the columns that are being declared is optional there. But just to be for clean code, we explicitly state what we're getting back, and then we wrap that sort of subquery inside of the CTE, and then we grab everything out of that common table expression. So when we run the query there, yeah, not very exciting. It gives you back the same information as the inner query does, but that's the foundation of mapping the CTE structure so that we can use it for some more interesting things later. All right, so let's move down here and take a look at using a CTE instead of a derived table. So derived tables or subqueries can get really nasty, and this is one of those that I've got a fairly small query here, but there are times that you might have like 4 or 5, 6 or 10 pages or whatever of SQL code that has the same derived query or derived table or subquery listed in it. And these derived table or subqueries, there's 2 of them that are identical right here. Is the first one. Oops. The second one is right here. And what you run into with these derived table queries is a problem of clean code, in that you've got copied code around all over the place, and when you go in and make changes, you might realize that I forgot to change one of them. And I know I've hit that on many occasions. So what I like to do is to clean them up and put them into a CTE so that they can get reused. Now here's an example of that same query, rewritten as a common table expression. Where right here we have that inner subquery, we have one occurrence of that. We have the name department CTE here, which is referenced here and here in 2 different places. So instead of having the same code repeated twice, we just reference that same named chunk of code through the common table expression. One of the things you want to keep in mind when you're doing a query like this, and this is one of those things that's often misstated on the internet, is that when you break it out like this, although you only have one occurrence of it in your code, it gets executed twice. So when you're looking at performance and things like that, you need to look at what is what's going on inside of here as being executed twice. If you have something that's really expensive or really long running and you only want to run it once, you might want to save that off to a temporary table or something. So we'll take a look at here at how it runs, and we're doing a self join between that, and that's the basis of building common table expression. So at this point, we'll hit recursive CTEs in another batch, but at this point, we're at our 5-minute list, or 5-minute timer. Anybody have any questions about CTEs or anything we've covered so far? Nope. All right. That must mean you guys are ready for the exam on this. Okay, so we'll close out the CTE example. Next on the list, what do we want to look at? We've got the following sections left to cover. Any preference? Anyone? Null. Okay, so null expression. Okay, awesome. We'll take on null expression and identity fields. And actually, that one counts as 3 because when we scheduled our time, we actually counted that out as, I think, it's 3 different sections that we're going to present. So I'll flip the timer over. This is my section, so I'll go right into null. We're going to use a very similar table to what we've been using. We're just going to drop the database and recreate it, start fresh. We're going to insert. Okay, so we'll just create the table, build it out. But what's different here is that this table is set up without specifying that any of the columns are null or not null. And what that means is that the default options for all columns is that they are null except for the primary key. So if we can use this statement here, insert into departments default values, and then select everything out of departments. And what that's going to do is it's going to insert one row, and it's going to then return it back to us. But that one row, it will get its primary key assigned, and then the other columns all got filled in with null because null or not null is not specified. Therefore, they can all be filled out with that default value of null. That's the equivalent of saying insert into department these columns as shown here with specifying null on each line. But it's a little bit faster to type the default values. However, from the kind of the clean code perspective, in some cases, you may want to call out specifically what you're inserting as nulls to be explicit about what you're doing. So if we run the second query here, you can see we get a second row inserted that's all full of nulls. All right, so let's insert some actual data. I'm going to fill in the table with 4 top-level departments: camping, cycle, snow sports, and fitness. And they're just going to get all filled out with null values. And then I'm going to select everything out of the table to show what we've got there. So you can see we've got 2 rows that are null, and then 4 rows that are real data that we're working with down at the bottom there. Okay, so let's take a look at how we can access that. Well, actually, let me put a few more departments in here. So under the category of camping, I'm going to select back the ID and put in these subcategories here. Pull that up, 4 rows affected. We look at what's there. We now have 2 bogus rows at the top that are null. Our 4 top-level categories, or 5 top-level categories here. No, maybe it was 4. Yeah, it's 4. And then we've got our 4 subcategories down here that are their parent is item 3, which is the camping category here. So that's the data we're looking at. But what if we want to do something with those 2 null rows that were in there? So what I want to do is select everything out of the department table where the department equals null. And I want to say, just while we're here, kudos, Bill. You were doing a really good job of explaining this yesterday when I overheard you and Jordan talking. It's almost like you were here for the previous presentation on it. But if we say select star from departments where department equals null, we get nothing back. And the reason is that in SQL Server and most databases, nothing equals null. Null is the special value that doesn't equal anything. We can even say select, and here's an example I heard yesterday, select null equals null. And for anything to equal itself, what you might expect is that you're going to get back true. But it doesn't work that way to say where null equals null. If you were to select back where 1 equals 1, oops, what am I doing wrong? I need to just, we'll skip that example. Thought I was about to do it. But nothing equals null in SQL Server. So, okay, you're learning that and you realize, okay, nothing equals null. You can never use equals null. So I'm going to try where it's like null. And in this case, okay, the query runs just fine. However, the problem you run into is since nothing equals null, the like expression doesn't work with null either. So you have to use something different. And you have this special thing where you use is null. Select star from the table where department is null rather than equals null or is like null. When we run that, you can see now using the is null function, we get back our 2 departments that have null as the department. Okay, so what can we do with that now? Well, the thing I heard yesterday when I overheard you guys talking about this, well, is the opposite of that going to be, can we do is not null? So if we run that and say, okay, give me all the departments where it is not null, we can go through and figure out everything that's not null. Okay, so what do we want to do? Let's delete those departments that aren't null. We'll try this, delete where department equals null. Oh, and then select star, it doesn't actually delete because none of them equal null. The way we need to do it is to say delete from departments where it is null, and then select from departments. And we can now see that using the is null is a way to get that back. So a couple, I'm just out of time here, but a couple things I want to hit on this. If you have null values, because we've looked at the is null function, but we can use the is null functionality, but we can use what's called the is null function to take a column and convert it to something that's not null. And we can use the null if to say if this column is null, or if this column equals nothing, then we can set it to null. I know we're zooming here on our time, but any questions on null before we move on to the next section? Okay. I'm going to leave that open, and we'll probably come back to that one a little bit later. So next on the list, any preferences for what we pick? Oops. Sorry about that. Merge statement. All right. We'll flip that over. That's Aaron's section. There you go.
All right, merge statement. We'll set up our inventory store table. All right, so what's commonly used is if you want to insert a row or update or insert a row into a table or update it if it exists, you can use 2 or 3 or more queries to do so. Like this statement here, we're going to update. We set our values. We update our inventory table on that SKU, and then we do a row count to see if any rows are affected. And if there weren't any affected, then it didn't exist, so we do an insert statement. We can see here 0 rows were affected with the update. So then it did the insert statement, and it also did a select star from inventory, so there's 8 rows there. So we'll run it again. And now we can see only 1 row was affected because it existed already. So now, I mean, that's not the fastest way to do it. You're running 1 query here to update, and then if it doesn't exist, you're running another query to insert. Some people can do a select statement right here on that item SKU to see if it exists. And then, so that can be 3 statements there. So the fastest way to do it is to have a merge statement. And what we do is, the syntax on that is merge into a destination table. I think the squiggly lines are the IntelliSense. It hasn't refreshed yet. So we merge into the destination table. We use a derived table as the source, which is just selecting our variables. We put a name for each of the columns from our source table. We define what the merge condition is, which is just on item SKU. And then when they match, so there's a match between our source table and the destination table on item SKU, then update the destination table with our source table values on these following fields for each item SKU match encountered. And when a non-match is encountered, then insert into the destination table the values from the source table. A semicolon is required at the end of a merge statement. It will not work if you do not have one. I'll run that. We were merging the blue hatchet values. We can see only 1 row was affected. It didn't do an update check first and then an insert. It just did the merge statement. And the 9 rows affected is the select star at the end. And we'll run it again, and again, and again, and again, and it's not changing any, we're only getting 1 blue hatchet in there and only 1 row. Well, 9 rows are affected now. So now we will add you can have an output clause on top of that. So when you do a merge, you could, if you want to get back an an identity value or do some logging. It's the same merge syntax. You have your destination table, your source table. In this example, again, it's only going to be 1 row, which is just variables. We have our column names, our merge condition, the when matched, and then the when not matched, and then we have the output clause at the end with the semicolon on there. So we're going to see this orange hatchet result set because that is what was inserted into the table. Skipping down, you can have 3 statements. You can have a matched, or 2 matched and 1 not matched. When you have 2 matched, one of them has to have an additional qualifier on it. It has to come before the just blanket match statement, because each row that the merge statement is matching on has to be, there can only be changed once. So this will return results that the blanket match statement won't. So that is why it has to come first. And that's about my time. Are there any questions?
The match and there can only be a single qualifier. Is that correct? You can't say and or.
You want me to take this one?
Sure.
So on the and, if you put the qualifier in parentheses, you could do multiple things inside of there, but it has to evaluate to just be one item that's returned from the right side of that and statement.
Gotcha.
Yeah. Okay.
Yeah, like that.
One of the questions that comes up oftentimes when I've seen the merge statement presented is, now that I know the merge statement, should I just stop using inserts and select, or inserts and update statements completely? And I think that's one of those things that it takes just a lot of common sense on it. Sometimes it's going to be appropriate to just say, let's just use the merge statement. And other times you're going to want to use an update statement or a delete statement or an insert as appropriate depending on what you're doing. But what I see as an advantage to using the merge statement is that if you start using it when you can, you will train yourself to know the syntax of that merge statement well, so that when you go to take the exam and you get one of those questions that says build a merge statement, you're going to be able to answer that question. Plus, it's a good practice. It's a feature that's there, and we may as well take advantage of it.
It's a very performant way to have logging, different logging, performing delete, inserts, or updates all in one statement, not including a whole bunch of additional queries or logic in a big long script, trying to figure out what to do logically. You can have it all in one statement.
Use the output clause for logging.
Yeah, you could use output clause for logging. You could have when matched, you could, update some other table.
So
if you wanted to. All right.
On to the next session.
Okay, close this one out. No. Control 1.
You want to mouse
Right. Mouse
down,
away.
mouse away, and
Mouse
then
away
there you go.
first. Okay.
Any topic, anybody?
Correlated subqueries.
Okay, good one. I would, however, recommend we do derived tables before we cover correlated subqueries because they build on each other. So,
Is that one you?
I'll click on it and see. I forget which one. That's one of these.
Yeah. That one's Steve.
Yep. All right. So the request was for correlated subqueries, but you really need the foundation of derived tables before we can take that one on. So let's go through this here and take a look. Again, as usual, we're going to drop the database. We're going to recreate the inventory table and put some stuff into the inventory table here like we've seen before. Sleeping bags, tents, axes, MREs, stuff like that. So we get connected. We've got 6 rows inserted there. And what we want to do is take a look at how can we get the items with the 5 lowest unit retail prices. Okay, so we haven't covered the rank function on the review yet, but the rank function ranks everything over a specific price. So if we just say select star and then rank of that, and notice I'm leaving out the where clause here for a moment, but we can see that the rank of the unit cost, every one of these gets ranked 1 through 6. And because these two are the same price here, let me zoom in, these 2 items are the same price, they get ranked with the same ranking over here of 3. And there's no 4 because the next one in order is 5th. I think some people called that like golf scoring or something. Well, but all I want back is just the lowest 5 unit retail prices. So when I look at that, well, I would like to just say where that rank item is less than or equal to 5. That makes sense to me. I go to run it, and I get this nice error message. It says windowed functions can only appear in the select or order by clauses. Okay, they can't work in the where clause. You cannot put that rank function in the where clause. So how do we go about doing that? Well, one way to do it, one way I thought would be, well, let's try the having clause. And I know the error message just said, didn't say anything about having, but I'll try it just to be safe. And you get a similar error message, it's invalid in the having clause. So let's use a subquery or a derived table. And really, when you hear the term subquery and derived table, they mean the same thing. And what we're going to do here is take our previous query that we ran that returned our ranking, put that here inside of parentheses. So parentheses start and ended, and then we're going to alias it. In this case, we'll just call it derived table. And then we're going to say select star from this parenthesis set, calling it derived table, where the derived table.rank unit cost, which comes from here to here, where it's less than 5. Now, because the ranking function was included internally in the select statement, it's okay to use, and the derived table is effectively taking all of the results and storing them off into a temporary place that they can be reused, and then we can use that derived table rank unit cost to get our results out of it. So really what we're trying to achieve is give me the 5 cheapest items. And at that point, we get the 5 cheapest items by taking that one query and just wrapping it inside of a subquery. Okay, now of the 5 cheapest products, show me those that are priced above average of the 5 cheapest. So take the 5 cheapest and what's more than the average price there. So in this case, what we're going to do is nest our derived tables, or nest, oops, wrong button. Is we're going to nest our derived tables. And kind of a big query here, but we have our inner one here, and we have our outer one, and in there, that's allowing us to do these aggregate functions, to do calculations that we can't use in the where clause, but because of the derived table, the way that it stores things off, we can use them later. We're then able to use those things in the where clause based off of pushing them into a derived table or subquery. And you can see one of the things I like to do when I'm debugging is you just run a chunk of the query inside by highlighting the inner query, running it. Okay, we can see that level works. Now we'll highlight the next level. Okay, we see that level works. That gives us back the 5 cheapest items. And then we run the whole thing, and we can see that it will give us back the most expensive of the 5 cheapest items, or those that are above average on the 5 cheapest. All right, so let's scroll down and take a look at using subqueries in the select column list. So here I'm going to say select star from inventory. Let me just zoom in on this one. I'm almost out of time, so we'll hit this real quick. Select star from inventory, but we're also selecting a subquery and saying select all of this stuff from inventory. And the way that this is going to work is the select star statement will get run to return everything back, and then for every row in that result set, it's going to run this subquery. So if you have 10 rows in your result set, that subquery is going to get run 10 times. If you have 1,000,000 rows in your result set, that subquery is going to get run 1,000,000 times. So you can see how quickly the performance would degrade based off of this subquery. And in fact, we've got 2 subqueries here. So that would be basically, with 1,000,000 rows, it would be running 2,000,000 queries to get a result set back. 2,000,001. One to run the first query, and then 2 additional queries for every one of those. You can see when we run it, yes, we get our results back, and we get this derived table column as it's been aliased over here. And that's it on the derived table section. So the next section that was requested that we're going to move into is correlated subqueries, unless there's any questions on derived tables before we go there. The key thing with derived tables is just think of it as subqueries, and it makes a lot more sense to me that way.
Set up our tables again for correlated subqueries. So a basic subquery like before, where if we know the IDs, it's not really a query. It's still a little filter there. So if we don't know the IDs, we can run a query here. We'll run both of them to verify the results are the same. So we know that the category ID is the category ID from categories where the category title is sleeping bag intent. All right, so let's see. How can I get a count of how many items exist per category? And we'll run the first result set is star from inventory. Second result set is a star from categories. And so this is where the correlation begins. It's we have a count from the inventory table, and we're correlating the I2 alias category ID, which is the inventory table, to the main query, which is categories. So we're correlating the subquery to the outer query on those two columns. We can, here's another one where we are grouping.
Just a note on that one. So similar to how I mentioned that with the subquery in the select keywords or select columns area, we'll run one for every row. In this case, this is being run once for every row, and it's just using that correlation to filter that result set. So it's being run once for every row with a slightly different query or a slightly different result set that's being returned on each one.
Yeah. So same query. We can have multiple filter or multiple conditions in our correlated subquery. This one is return a count of all the items in the category from the inventory table, where the inventory item is not the same in the correlated query as the one in the main query.
We have a question that's come in on CTs and subqueries, and I'll address that question when we get to the end of this 5-minute block.
Okay, so we can see here a count of sleeping bags or other sleeping bags in the sleeping bag category returns 2 for each of them because it is excluding itself from the correlated subquery. And then we can use isNull to count. When we wrap the correlated subquery or just subquery, we can wrap it when it's in the select with an isNull. All right, subquery extensions. Subquery extensions are the any, sum, and all. Or yeah, any, sum, all, and exists. So the all is give me the results from my correlated subquery where all of the matches have a quantity on hand greater than 5. So in this example, so we're joining on category ID, which is ones or sleeping bags. And since we use the all extension here, any rows in this correlation right here where the quantity on hand is less than 5 will not return a result. We're asking for all, so where they all match. So sleeping bag has a record of 1. 3 records, one of them is 1, so it's not returning the result set. Tent and axe both have 5 or greater, so those are the only 2 returned. Food has a category of 1. When you use the any or sum operators, sum is the ISO equivalent of any. If any of the records that match have a quantity on hand greater than or equal to 5, then it returns that category. So each of the categories have a quantity on hand greater than or equal to 5. The sleeping bags, the tents, and the axe and the food. So all of those results are returned. And the exist is same result set as the any and sum. However, it stops processing the correlated subquery when the first true instance is returned. So it is more performant than any and sum. So you want to use that one over those other 2. All right, that's my time. Is there any questions?
I'll take the next question here as soon as there's no questions on correlated.
No questions.
All right. So the question came in really, I think what was being asked here is what's the difference between a subquery and a CTE, common table expression? And there's a handful of differences in it, and I think one of the things that might have confused us a little bit is the way we presented today, sort of jumping around with whatever topic people want to cover. Usually I would cover subqueries prior to covering CTEs, and then do base CTEs, and then go into recursive CTEs. Now, because of that, I mean, a little bit about a sequence, it wasn't entirely clear. So one of the there's a number of differences there between CTEs and subqueries. Subqueries are more of a standard in that the way we've looked at the subqueries, or we've shown them here, most of the functionality that you've seen, other than some of these extensions, will work the same way on Oracle, on SQL Server, and on MySQL. With common table expressions, although the concept is supported on other platforms, it's very different on those other platforms. So if you're trying to write portable code or cross-database code, like the SQLite or something like that, subqueries are going to work much better for you in that case. Another thing that's different is just clean code versus having code replicated many times. With the common table expression, if you have subqueries as an alternative to a subquery that's used 3, 4, 5, 10 times in a bigger query, your code's a lot cleaner by breaking out into a CTE and then just referencing that by name. Whereas with a subquery, you have to use it many times. Another difference, and we'll go into that next, is recursive queries. With common table expressions, you can do recursive or hierarchical type queries, and you can't do that easily with subqueries. So, I don't know, anything else that good to point out? I guess one more thing to point out: if you're using a query that's has a CTE that's referenced multiple times, or you're using a subquery that's identical to that CTE being used multiple times, the performance is identical. There's no performance gain there whatsoever, other than you get cleaner code that way.
Yep. And an alternative to repeating the same query over and over again, someone might say, would be, well, I'll just fill a temporary table with the results from that subquery and reference that temporary table all over. And that in itself is slower than just using a CTE.
However, it does depend, because there are cases if that makes a lot of sense to do it that way. If that query that's being run as the subquery or the CTE is really slow and you can't afford to run it multiple times, put it in a temp table and use the temp table instead. It's a great way to do things. So they're all tools to do things a slightly different way, but I'm going to not ask what we want to do next. I'm just going to go into recursive queries here real quick, because the question, I think, has led us right into that. So recursive queries are something that is awesome to do with CTEs. Flipping over the timer here. And there are other ways to do it with like recursive queries or functions or procedures, but it's usually just a pain to do it that way. Keep in mind the word recursion is when a query calls itself. That's kind of a weird concept. For those with programming background, you probably know recursion in whatever your favorite programming language is. But let's take a look at how we can do that with a query. So we're going to drop the database recreated. We're going to create the same royalty table I created earlier and I didn't actually use. And we're going to fill it in with the British royal family. Okay, we get a bunch of rows inserted. And when we select out of here, we can see we've got George V, King of England. And then as we go down, you can see the youngest one in the entire tree is Prince William right here, with his parents being 16 and 15, which is Charles and Diana, and their parents being shown there all the way through. So let's take a look at how we would do that as finding parents using, or finding a hierarchy using common table expressions. So there's some self joins, we'll skip over that. But what I want to do here is use a common table expression and to do a recursive call. And when you put the union all inside of the CTE that has another query associated with it, that's what really turns it into a recursive query. So the way this is run, you have an anchor query here that says select star from royalty where the ID equals 7. Okay, translating that, it says give me Prince William, give me that row. And then it says take the results of that set and union all of the results with this other query, which is saying give me everything from royalty, interjoining back to the CTE itself. Here's the name, joining on mother. So it's going to say give me Prince William and his mother, and then for his mother, get his mother's mother and his mother's mother's mother all the way out in that direction. And this top part is called the anchor query. The bottom part is called the recursive query. And then we're just going to select out of the CTE at the bottom. So let's take a look at what that does. When we run it, you can see we get Prince William, his mother Diana, and Diana's mother of Francis. Okay, so that gives us kind of one leg up the family tree there. We can take a look at the other side, and if we take the previous query, and all we're going to do is change it and join on father instead of mother, and you can imagine what that's going to do. It's going to get Prince William's father and his father's father, and the line goes back a little bit further on that side. So it goes William to Charles to Philip to Andreas to William George the First of Hellas. Okay, so what if we want to look at both sides of the family tree with a recursive query? Well, we start out with this similar to what we looked at before, where we say start with Prince William because he's at the bottom there. For every result that's returned, go find the father. Then for every result that's returned, go find the mother. Now, some people say, well, which one of these gets run first? And with the recursive query, you can think of it kind of as walking out the levels further and further as it goes through the depth of the tree. And then it starts with the anchor query, and then it goes and does all the recursive queries for the results returned from that anchor query. And then it does it again and runs all those recursive queries for all the results that were freshly returned. And it keeps going and going and going indefinitely until you run out of until you hit the max recursion, or until there's nothing left to return. So in this case, when we run it, you can see it now lists everyone out. It gets everyone in the tree, and it's very similar to what we requested to begin with, but you can do some really cool stuff by doing using tree path, concatenating some things together here with the recursive query. And now we can see you can piece together all of the different levels. So for everyone in the tree, they're an ancestor of William, Prince William in this case. And we can see his father and his father's father, his father's mother, and all the way through the tree. Given that we're a little bit short on time here, I'm going to skip over some of the other formatting and take a look at another example of doing a recursive CTE. Common math sequence is the Fibonacci sequence. And the Fibonacci sequence starts out with 0 and 1, and it's defined as the next number is the sum of the two numbers added, or the two previous numbers added together. So it starts out with 0 and 1, and the next number is 1 because 0 plus 1 is 1. The next number is 2 because 1 plus 1 is 2. The next number is 3, and then 5, 8, and so on like that. So here we'll start out with our anchor query, select 0 and 1, and when we run this, that's, oops, what did I do? Highlighted it wrong. When we run that, it's not recursive, it's just starting at the top level. But then what we're going to do to make it a recursive query is we're going to use the union all statement, select from Fibonacci, which is the name of our CTE here, and it's referenced down here. And we're just going to select the number and keep adding to it where n is less than 1 with a whole bunch of zeros, 1 billion maybe. So when we run that, oops, wrong spot there, we highlight it, and you can see it then calculates out the Fibonacci sequence. And to go to that high level, it's only 45 levels deep. The thing you want to keep in mind, we're going to add a couple more zeros on there and run it again. Max recursion. So the max recursion is by default, max recursion is set to 100, which means as it's recursively going through each of these levels, only do it 100 times. And if it goes beyond that, then let's abort. So here I'm going to put a couple more zeros on it. I'm going to overlook the max recursion, and we get, arithmetic overflow and int. That's not quite what I was trying to show here. But the point is you want to be able to go beyond that 100. You can specify a max recursion of a specific number, or you can just leave it at 0, which says give me unlimited recursion. Now, if you goof and don't have something that's going to terminate your inner query somewhere along the way, that max recursion will go until SQL Server runs out of memory or indefinitely at that point. So just keep that in mind. That's all I have time for on our block on recursive queries. Any question on recursive queries with CTEs? Okay, we'll close that one out and on to the next topic. Any preferences here? Output clause. All right. That's a fun one. That's mine. So,
Are you gonna use it?
all right. So on to the output clause. Again, create the new query training database. We'll use the inventory table and departments table, kind of like we've looked at before. We'll put some stuff in them, run the query, and then let's look at what we've got there. So for departments, we have a list of the same kind of departments we've been looking at previously. And then for our inventory, same kind of inventory we've been looking at in the previous examples. However, somebody threw some pizza in down at the bottom there that I didn't see earlier. Okay, so let's take a look at an insert statement and how we can use the output clause with it. Now, normally when you think of the insert, update, and delete statements, you think of those as performing an action, and the only thing you get back is the number of rows affected. Same thing with the merge statement. But what the output clause does is it will let you do those modification functions, input, insert, update, and delete, and then give you a result set back to show you what actually happened with that. So let's take an example here. I'm going to put in an MRE of chocolate ice cream, and I'm going to and then I'm going to select from inventory. There's no output clause in this one. This is just a general query. You can see all we got back from the query was 1 row effective or 8 rows effective on our second query, or affected, and we don't get any details back on what was actually changed. But if we add in, like on this example, we're just going to add output the inserted dot star. What that's going to do is it's going to run the insert statement, and then it's going to return a result set back that shows us the entire row that was inserted. Now keep in mind that this table has an integer identity on it that's going to be the primary key that increases after every insert. And even though I haven't specified that on my insert statement, which you normally wouldn't, it's going to return that value. So if we just highlight that one function without the select star down below, just run it, what we get back is the entire result set with any of the default values or other things specified of the row that was inserted. So you can do an insert statement, and that's a great way to get your identity value back. It's better than some of the other options because you know for certain that this is going to be your identity value. Now let's scroll down, and here I'm going to jump into inserting. Oh, did we not turn the timer over on this one? Or, yeah, all right. So I'm going to insert 2 values, and what's different when we insert 2 values is we're going to get back a result set with 2 rows in it. Now, if you're using some of the other functions that will give you the identity value back, you normally only get 1 value back, but in this case, you've actually inserted 2 rows, and you can get back the inventory ID or the primary key int identity of what was inserted along the way. Update statement's very similar. Let's take a look at, we've got this one here of this MRE of ice cream. We'll just do a simple update statement. Without output on it, we get 1 row effective. That's the only row we get back.
I have a question. Can you modify the values in the output, for example, concatenating something to it?
Yes, that's a great question. And I think that similar question was asked when we did the training before. So we should add that into our training going forward. Let's take a look at that. So here, let me just jump back up. No, let me keep going here for a second, and then I'll cover that. So I'm going to update inventory. I'm going to output the MRE, or I'm going to set the description equal to triple chocolate chip where the item SKU equals this value. But what we're going to output is a special table name called deleted and a special table name called inserted. So when we run that, you can see we're getting back the inventory ID before, and over here the inventory ID after, the description before and the description after. So the question was, well, can we modify them or concatenate or do different things with them? So if we just change the record here to be deleted dot description, and I'm going to say plus and concatenate a new value colon and then plus and add on description like this, and I'm going to call it, just to get crazy, hopefully quadruple spelled right, but quadruple chocolate chip. And when we run the query now, you can see we get a single column back that has the value before up until this point, and then the value after concatenated into one function or into one column output. that answer what was being asked, or did I?
Yeah.
Yeah.
That answers it.
And then you could do other things, like you could put functions in here, or you could even put like, I don't know, test output. You could as some column, and when you do that, you can get other columns in the output there as well.
Like a subquery too, like a select?
That's a great question. Can you do a subquery or select in there? Select count 1 from inventory as num items. Okay, let's run that. Let's put a caricature in there so we can see it a little bit better. Subqueries are not allowed in the output clause. So, yeah. Didn't know that one, but thanks for asking the question, because we all learned something there. So you cannot put subqueries in there, but it was a good try. And then you can also use the output clause. Here's an example. We're going to create this table called inventory temp table. We're going to update, but we're going to output certain columns into this temp table. Then we're going to select everything out of that temp table. And so that temp, it's simulating what you can use a temp table for if you wanted to do other data manipulation afterwards. And so the output can be inserted into another table. I think that's all I have time for on this topic.
Okay, there's no more questions over here.
Okay, any other questions on output clause while we're here?
Just to mention, that happens before the trigger. Any triggers would fire, right?
Yeah, so that's an interesting thing. It happens before any triggers fire. So the inserted and the deleted column names that are referred to in here, those are the same names that you get when you're working with triggers. And if there's a trigger on the table and you're using the update statement, the output clause, the values you're getting on the inserted and the deleted values are the values before any trigger was applied. So if you have triggers, this is the result before the trigger did anything with it or modified anything or used it in any way. Yes. Yep, exactly. All right, next. We're down to 3 left. Aggregation. I guess we've got expression, and expression is one section, identity fields, and then top rank and dense rank. Any preference? All right. What? Ranks? Did I hear rank?
Yeah.
Okay. Over to Aaron on this one.
So rank, set up the data. Right. So first we'll cover the top. The mouse here. So you can use the top qualifier, I guess, or keyword to grab the top X or N rows of your query. If you do not specify an order by, here's the select star. This result says the select top 3. If you do not add an order by on there, you can get a relatively random result set just based on what's going on in the table. There's no way to guarantee the top 3 rows are what you're expecting from that table. You're just kind of giving it up to the SQL Server to decide. Like I said, you can use a variable as the how many rows you want returned. In this case, top 3 rows. You need to add parentheses when you're using a variable. In this case, when you're using just a number, you do not need the parentheses. There's with ties, so we'll add this. We'll run these statements first. So the first result set is a select star from the inventory table. The second query is a select top 2 for sleeping bags ordered by unit cost descending. So sleeping bags is select top 2. If we add a with ties, on there after the select top two, we get 3 results, even though we said a select top 2. And that is because with ties, we'll return any other additional rows that match on that value. So if they all were sleeping bags and they were all 575, then all of the rows in the table would be returned. You can also use top n% of the table. Top 0%. The first result set is select star. So we can see we have 7 rows. If we do a top 0, it returns no rows. Select top 10%, returns 1 row. 20%, 2 rows. It can also be with a larger data set. You could use decimals if you wanted to get a more fine-tuned result set. Okay, so I just have a decimal percentage here. So can you delete the top 3? Yes, you can. Have it in the begin trend, rollback trend to keep our data. But it's not a safe thing. In this example, I didn't have an order by on there, so I'm not sure what top 3 rows are going to get deleted. Hopefully it's ones you don't want.
Delete any 3.
Yeah. So can you do an update on the top number? No, you cannot. So how can we, well, can you do a top 3 in an update statement? No, you cannot. So how can you how can you get it done? You can have a subquery, and it could be a correlated subquery in the update statement, which selects top 3. And if you wanted to correlate it, you would do where the subquery matches the outer query. So we can run that one. You can see here that we updated the quantity on hand. We subtracted the quantity on hand for the top 3 quantities on hand by 5. So the 35 here is now a 30. The one of the 5s is now reduced by 5, and the 13 is reduced by 8. So what if we want to do with ties? Does that affect more rows than just 3? And it does. Here's the 30, which was 35. Here's the 8, which was 13. Here's the two rows up top that were 5, and then there's a 5 down here, and that was reduced to 0 as well. And then there's rank. Rank is a way to apply a ranking on rows based on a certain column. In this query, it was rank over unit retail. And we can see unit retail right here, ascending. So this lowest price here is ranked of 1, ranked of 1 again. Difference between rank and dense rank is dense rank continues on with the sequence when a duplicate is encountered. So we can see here that there's 2 1999s, so the rank went 1, 2, 3, 3, 4. With the rank, it went 1, 2, 3, 3, 5, and that's because it continued on with the current row number that it was on. And I believe that's my time. So, is there any questions?
In some of your examples, you combine top and percent. Can you do top and ntile as well?
Combine top and percent.
Like top 3%, so like top 3%. Instead of using percent, could you put ntile there?
No. The question was, could we use ntile or any other function for that matter in place of the percent keyword in the top 20%? And the answer to that is no, you can't. The percent is a special keyword that only applies to the top value like that. If you wanted to display a certain amount of an ntile, you could wrap it in a subquery and then use it in the where clause. That'd be a way to get it back, or to delete or whatever you may be doing with it. But you can't. It's either top number or top number percent, and those are really your only options at that point.
All right. Any other questions?
what have we got left on the list to cover on the drop-down corner there?
Aggregation strategies, expressions, identity fields, and that's it.
Okay, so I mean, we'd allocated our time, and I planned for the last 15 minutes just to be to any open questions about anything we've covered at this point. So I'm thinking I'm going to hit the other sections. We can follow up in the previous videos if we need those, and we're running out of time. Any questions about anything we've covered at this point? Okay. So why don't we jump into identity fields then? So I think that's fine.
Sure. Yeah.
All right. Just want to make sure we don't miss any of the questions we're trying to get to. So identity fields. Here we go. All right. Now, an identity value in SQL Server is a way of specifying on a table that this is going to be a numeric value that's going to be automatically incremented for us as we insert to it. So by taking an integer or a small int or a big int or whatever the type is there and putting identity on it, it's basically a way of saying automatically incremented. So let's take a look at how that works. We're going to drop our query training table, or our database, drop the database, and then we're going to create this table called departments. And in the departments table, we're going to have this identity value as the primary key that's of type tinyInt. We're going to start at 1 and increment it by 1. That's what these values here mean. Start by 1 and increment by 1. And I've talked to some people in the past who said, well, let's increment by 7 or 12 or some crazy number like that. That's just waste. I mean, it doesn't really make any sense to do that. I always try and increment by 1. Now, with the tinyInt value, if you don't remember what that is, it ranges from 0 to 255, and that's all it can fit in a tinyInt. So that means that this table can only hold 255 rows. So let's take a look at that. We're going to insert it into department default values. We're going to run it 255 times. And as we page through the result set, you can see we got 255 rows inserted if you're counting all of these one row affecteds. Now let's just do a quick check. Select star from departments and see what we've got there. Oops, typo. You can see we've got 255 rows that are all full of nulls, but we do have 255 rows. Now the thing with this is, let's insert one more row, and that's where things blow up. Because the tinyInt can only hold 255 numbers, that's saying this table can only hold 255 rows. Well, not very useful for most tables. And honestly, the performance difference you get there between a tinyInt and an int isn't going to be that great. So especially since you're only going to have 255 of them, you're not saving that much. So let's look at the same thing, but we're going to use integers. So here I'm going to drop and recreate our database from scratch. We're going to create the departments table. Whoops, I'm in the wrong spot, it looks like here. Oh, I had a typo here. This is supposed to be integer. I'm going to create a table where the ID is integer and the identity value is going to start at 1 and increment by 1. We're then going to insert 32,767 items into the table. And that'll run for a minute. So what it's doing, the maximum value, oh wait, hold on, back up. I goofed here. That was not a tinyInt, that was supposed to be a small int, that was correct. So the small int, and this example is going to fail at this point, the small int can hold up to 32,768. And then what it would have done is the same as the other one and failed at 255. So what I want to do here is stop the query from running. I'm on reviews. We haven't done this in as much detail as we did before. Now what we do is do the same thing with an init. Where is it here? The small int, if we wanted to go beyond that, we can seed the table with negatives. Now, before we started with 0 or 1 and incremented by 1. In this case, we're going to seed the table at the smallest value that you can hold in that small int, which is negative 32,768. And what that does is it gives us twice as many identity values that we can use before we run out of space. So we run that, and I'm not going to run through it here because we don't have time to run it in the 5 minutes. It's going to insert 32,767. We're going to insert a few more, and at that point we would see that the values were right around 0 at that point, and then they would start incrementing up from there. We can reseed these tables and sort of override it where let's drop the departments table and recreate it as an integer identity where we're going to start at 100 and increment by 1. We're going to insert some default values, 20 of them. We're going to select out of the departments table and see we get IDs 100 through 119 down there. And then what we're going to do is we're going to insert into departments with an ID, which is our identity value of 1. So let's run that, and it fails. It says you cannot insert explicit values for an identity column into the table departments when identity insert is set to off. Okay, that's giving you a clue. Maybe there's a way around it. So what we do is we do the set identity insert for a table to on, which says, I know better than SQL Server what's going to happen here with these identity values. I'm going to override it, and even though you're not going to normally let me do it, I'm going to put a specific value in there. So in this case, we're going to turn it on. We're going to insert with a 1, and then we're going to turn that identity insert back off. So we're back to the default value. So now when we run it, we can see that the identity value has a 1 and it has 100. And this could be an example of, like, let's say you're keeping track of account IDs, and you want to say all the account IDs less than 100 are going to be demo accounts, and all of them above 100 are going to be real customer accounts. You could use this to sort of fake the ID to go into that lower range. Then we're going to insert. What happens when we insert our next row now? Do you think we'll get a 2, or do you think we'll get a bigger value? Okay, so when we run it, we did the insert and we selected star. The 1 is there, the 100 through 119 is there, and then the next value that was inserted is 120. Because when you're working with an identity, even though you've inserted a lower value, the next one inserted is always going to be 1 greater than the biggest value in that entire table. So let's try this then. Let's set the identity insert into the really big, or set it on. We're going to insert a really big value. If I remember correctly, that's the maximum value that will fit into an integer. We run it, and then we're going to say select star from department, see what we've got. Okay, and I ordered by the ID descending, so we've got that really big value there. And then let's just try inserting one more row with the default values and run it a couple times because we're almost at the very edge of an integer. We run that, okay, we get the 4.6 at the end, we run it again, we get 4.7, and then we get overflow where we've now blown out what can be held in an integer. And we can use the dbcc check ident function on the departments table to see what it's set at. And it says that the current identity value is this, and the current column value is that, meaning we're maxed out on there. So let's try using the check ident to reseed it and say, well, we've got this room on our negative side. Why don't we just reseed it and set it back to -5? Okay, now we know between the value of the maximum integer there and -5, there's got to be some free space. Will this let us insert to it? Let's give that a try. So we run insert. We get one row inserted, and then we select from the table and take a look at what's there and scroll down. Our -5 got incremented to -4. So let's run it again with another insert statement. Our -4 got incremented to -3. Now to a -2. Now to a -1. We get a 0. And what happens now is it's trying to insert the next value greater than 0, which is a 1. The table already had a 1 in it, and it blows up and says, primary key constraint violated. Don't do that. It won't let you do that. So if you're using the reseed function to set an identity to a lower value, and you keep inserting rows, think of it only as a temporary band-aid. It's going to hit a point where you can't insert any more after that. After you insert, you can get back. And actually, we're running out of time here on this one, but there's 3 ways to get back your identity value here: add identity, scope identity, or ident current. But the better, and then there's another way, the better way to do it is to use the output function like we just looked at earlier to output the value that was inserted. And that's it on the identity value. Questions?
The output inserted is the only way to always be correct on identity, but
The statement was the output function, or the output using the inserted ID is the only way to guarantee that it's always going to work. I would say, yeah, that's a fair statement. There's other times you're going to get lucky, it's going to happen to work, or it might depend on the scope or the load or what other people are doing. You might get lucky and get the right number back. But with output, it's going to return multiple IDs. If you have multiple of them being inserted, it's the only way to get that back. And it's the only way to truly guarantee what's coming back is what was absolutely inserted at that point.
Isn't scope identity guaranteed?
No, it's not. And the reason it's not is because it's generally good. And prior to understanding the output clause, I'd say, yeah, you should probably use that most of the time. But scope identity, what will happen if you do an insert and a trigger fires, and based off that trigger, it causes an insert to happen in another table, you're going to get the identity value out of that other table, not the one that was inserted on this row or on this table. Whereas if you're using the output clause, you will get absolutely the one that was inserted on this table.
I thought that was for the identity. So we had switched from doing identity to doing scope identity because of that trigger issue.
Yes. And not, well, let me just bring up the slide and check that one to make sure I'm saying this correctly. I know I outlined that in the slides here. So add identity returns the last identity value across all scopes. Scope identity, last identity value for any table in the current session and current scope. So scope identity will get a value from a trigger. It's better. And then identity current is the last for a specific table. But if somebody else inserted the table, ident current would be, I mean, out of all of these, I think ident current is one of the safer ones, but scope identity is generally what people use for the reason you explained. However, the output clause is the only way to really guarantee that you get it right. Any other questions at this point? All right, we're about out of time, so let me just go back and wrap up the slides here. So the list of everything we covered is the first section here. I'm not going to run through it all again. So for more information, you can visit Emergency Reporting to find out about more about the company. You can find Aaron or me on the web, with our websites or on Twitter. And next week, what we're going to be covering will be, where is it here? Using cursors, or more specifically, how to use cursors, but when to not use them, and then string functions. Any other additional questions coming in there? All right, that wraps up the broadcast for today. Thanks everyone for joining us.